get ready for tomorrow's quiz.
Yeah.
Let's pay attention. I'm expecting good grades tomorrow. This is pretty simple, isn't it? All right. So remember, this is where N was when we started, and that's where A was, right? When we started these. So N is what for this problem? 6, and A is 64. Now, some of you just put that in your calculator to see if that did it switch over? What happened? Let's see something. Oh, I don't need that one. So, is this working now?
I think both so far.
Why didn't it work over there? Oh well, I guess you guys will have to turn your heads to the right. All right, so I'll just show you the work, but you can just put it in the calculator and you'll see what the answer is. But showing the work, I would go 8 times 8 and 2 times 4 and 4 times 2. So how many 2's do you see? 6, and my index is 6. So since I'm looking for a group of 6, my answer is 2. Okay? So I don't know why my board is messed up here, but we'll fix it hopefully. All right. Number 2 is a equation we have to solve. So I've got x plus 7 to the 4th power equals 256. So when we do these types of problems, you want to get the part that's raised to the power alone, which is already done, right? But if there was a number in front of the x plus 7, like a 2 or a 4 or anything, all right, I'd have to move it over. If it was just a number in front with no symbol, I divided. If it was 3 plus that, I subtracted, right? But I didn't have to do that, okay? So all I got to do is take what root of both sides? The 4th root, yes. And what is the 4th root of something to the 4th power? Itself, right? So that becomes x plus 7 on the left, because the 4th root and the 4th power basically cancel each other out, right? Now, remember, we talked about this when we did this first day of this. If it's an even root and it's a positive number under the radical, or that we call the radicand, what symbol goes in front of our answer? Plus or minus. So don't forget about that. And what did you guys figure out for the 4th root 256? It's a 4, right? 4 to the 4th is actually 256. Okay? So that's what I have right now. To finish up, to solve for x, what do I have to do now? Subtract 7, right? So, when we were doing the quadratic stuff, we would write answers like this a lot when we had radicals, right, in our answer. Okay? So there's 2 answers there, right? Negative 7 plus 4 and negative 7 minus 4. So make sure you get both answers, Caleb. Then you don't put the plus or minus. The index you're talking about?
Yeah.
Yeah. if this was to the third, we wouldn't have to put the plus or minus. Then I'd be taking cube root. Or if it was to the fifth, we'd take it the fifth root. I wouldn't have to put the plus or minus. There'd be only one answer. Good question. But if it's an even index, then it's a plus or minus. Okay? We good on number 2? All right. Number 3, we have it written in radical form, and you're supposed to write it in exponential form. All right? Our radical is the fourth root of x cubed. All right? So the index, is that the denominator or the numerator? The index. Denominator or numerator? Denominator. Exponent, numerator. So just don't switch those, all right? That's all we're asking. That's a rational exponent. A rational number, remember, is a fraction. Okay? All right, number 4, we're going the other way. We've got it in with a rational exponent, and we're supposed to write it in radical form. Okay? So remember, the denominator is the index, or is it the exponent? The index. So the 5's out here. So the numerator, the 7, is the exponent. So we're not actually solving it, we're just rewriting it in the other form. All right? Yes, Jordan.
So I had like the 5 as the index, but then I like put like the 4 as the fifth root of 4, and then I put parentheses, and then there was a 7 outside.
Oh, that's okay. You could do that. Here's what Jordan was saying. Oops, not a 4, sorry. So Jordan was saying, is this okay? And I would say, yes, that's okay. So if you wrote it either way, you're good. All right, number 5. So we have x times x to the 3/4 over x to the 1/4. Well, here's what I look. When I see those two fractions, all right, and they have the same base of x, I'm just going to do what with them? Subtract them. Where's the higher exponent? Top. So what's 3/4 minus 1/4? 2/4, which is 1/2, right? So I was just looking at these two and making it x to the 1/2. All right, that's what I was thinking. But not the only way you can do it. Now, what's the rule here with these exponents? Remember, that's a 1 there. What am I supposed to do with those exponents? Add them. So what's 1 plus a half? 1 1/2, which as a fraction is 3/2. Okay. Some people might have added first. What's 1 plus 3/4? 1 3/4, right? All right. And then subtract the 1/4. What's 1 3/4 minus 1/4? 1 2/4, right? Which is 1 1/2 again. So the way I did it isn't the only way you can do it. Any questions? Okay. Number 6. We're just simplifying again. What's the rule? If I have an exponent inside the parentheses and then outside, or a power to a power, multiply. What's 4 times -6? -24. When we simplify these types of problems with variables, are we allowed to leave our answer with a negative exponent? No, right? So how do I make it positive, Sophia? Right. Put the 24, make it positive, it has to go to the denominator. Okay, so that's what we're looking for number 6. 1 over y to the 24. Okay. Number 7. We've got a 4th root of 3 over the 4th root of 2. First thing I would look at, since they're the same index, can I divide 2 into 3 and get a whole number? No. I would try to simplify that fraction if I could, since they're the same index. I can't do that. So am I allowed to have that 4th root of 2 in the denominator? No. So how do I get rid of that 4th root in the denominator?
You multiply it by the 2.
How many 2's? 2. Since it's 4th root, how many 2's do I need to get rid of the radical? I need 4 total. So I need how many more? 3 more, right. So I need 3 more 2's to get 4 2's in the bottom. You guys with me on that? You see this number? That tells me how many of that number I need. All right? So I have 1, 2 here. If I multiply by 3 more of them, I have a total of 4 of them. Okay? So when I multiply the bottom, what's 2 to the first times 2 to the third? 2 to the fourth. That's what it looks like. So what's the 4th root and the 4 exponent do to each other? Cancel. So my denominator becomes just a regular 2. The radical's gone. But remember, whatever we did to the denominator, we had to do to the numerator, right? And what is 2 times 2 times 2? No. 8, right? So what's 8 times 3? 24. So this up here is a 24. And I can't simplify that. There's no group of 4 of a number in there. So our answer is the 4th root of 24 over 2. We got rid of that radical or 4th root in the denominator. We rationalized our denominator. Okay? Number 8. We got a similar situation here. We have a square root of 7 in the bottom. And we can't have that, right? So we have to use what we call the conjugate of 5 plus the square root of 7. What is the conjugate of 5 plus the square root of 7?
Just the opposite.
5 minus the square root of 7, right? So I'm multiplying top and bottom by the same thing. Now, what's 1 times anything? Itself, right? So the top, 1 times 5 minus radical 7 is that. All right, when I FOIL this, what's 5 times 5 for first? 25. What's 5 times negative radical 7? Negative 5 radical 7. What's positive radical 7 times 5? Positive 5 radical 7, right? What's a positive radical 7 times a negative radical 7? That, right? Well, what is the square root of 49? 7. Okay, so my answer then is 5 minus the square root of 7. What happens to these two in the middle? They cancel, right? So what's 25 minus 7? 18. There's our answer. We have simplified our expression. Do you have a question, Vince?
Where'd the square root of 49 come from?
I multiplied radical 7 times radical 7. So that was 49 in there. But that's a perfect square. So that's why the 7 came out. A positive times a negative is negative, so that's why it's minus 7. Okay? Any other questions? So the mistake some kids make, focus up here, is you put plus there. These two got to be opposite signs. Okay? If it's addition underneath the original, then it's subtraction for the conjugate. All right? That's where we make a mistake sometimes. Don't do that. Mistake, okay? And FOIL the bottom, distribute the top. If this had two terms up here in the top, we'd FOIL the top also, right? And it's okay to have a radical in the numerator. You don't have to worry about that. Number 9, we're simplifying an expression. We got the cube root of 54, x to the 4th, y to the 12th. So I'm just going to show all the work. You don't actually have to do that if you don't want to, but I'm going to say 9 times 6 for 54, 3 times 3, 3 times 2. For 4 x's, I want to put them in groups of 3 because it's cube root. I'm looking for groups of 3. So that's my 4 x's and my 12 y's. And I did my factor tree for my number. So I'm looking for groups of 3 because it was cube root. So for this group of 3, I pull a 3 out, right? For this group of 3 x's, I pull an x out. For this group, and that one, and that one, and that one. I can pull those out. You with me on that? Now that's showing all the work. Now some of you remember that you can just divide the exponent by the index, right? Now what's left? What's not? You know the 2 also, see that? All right, so to write this properly, I got a 3, an x, a y to the 4th, cube root, 2x. So there's our answer. But I was just trying to show you why with all the work. Okay? Questions on 9? If that helps you to do it that way, go ahead and do it that way. Last one. We got x times the square root of x to the 5th minus the square root of 25x to the 7th. As they look right now, those two radicals, I can't subtract them, right? They have to be like radicals. But a lot of times we can simplify those radicals and they become the same. And that's what's going to happen, right? So again, there's no index written there. So I'm looking for groups of how many? 2, right? That's square root. We're looking for groups of 2. So for the x's, there's 2, 3, 4, there's 5. So I have 2 groups of 2. 2 groups of 2 x's, right? So I've got an x out there, a blue one, and now 2 green ones, right? If I do show all the work. Okay? And then we have an x left over, right? You guys okay with that? Where I circle with the green. So there's 2 x's there. So there's that one. 2 x's here, so I bring another one out. Okay? Really, do I need to do a factor tree? What's the square root of 25? 5, right? So I know the 5 comes out. Right? And then if we do the x's in groups of 2, all right, I have 3 groups of 2, right? And then this is left over. Oops, that should have been purple, huh? Just keep doing what I've been doing. Okay? So let's, write those the way they should be. 3x's, how do I write that? X to the third times the square root of x minus 5 x to the third times the square root of x. Are they like radicals now? Like terms? Yes. So what's 1 minus 5? Negative 4 x to the third square root of x. And I went through my negative sign. Not good. Questions? Is this that difficult? No. It's simple, right? So I'm expecting 4 points apiece, 40, 35s or better. 40s, lots of stickers tomorrow. Okay, Miller?
You know, slime that was out in my bag.